So hello and welcome everybody to our Mosel release webinar about what's new in Xpress Mosel in Xpress 8.9, which will be presented today by Susanne Heipcke. First, before she starts, I want to give you some technical details about how things are handled today. So we respect your privacy. Every one of you is on mute at the moment. If you have any questions, please raise them via the Q&A, and Susanne has planned for several breaks in between to answer those. And those that we may not be able to answer today due to time restrictions, we try to answer them later on by email to you. Another thing to notice, in case the slides look truncated to you on your PC, on your laptop, on your screen, please, on top of this Zoom recording, there is an view options drop down. Go to Zoom ratio and click fit to window, and then you should be able to see all the slides. If you have any other technical questions here, please, we can, Joe and I will be available for responding to them. And now over to you, Susanne. Looking forward to your presentation.
Well, thank you, Jens. Welcome everybody to today's webinar. I'm going to talk about what is new for Mosel in the most recent Xpress release 8.9. The Xpress Mosel version that we have released is 5.2. Okay, so I shall start just saying a few words about Mosel, its history, and where we come from, where we are now, and then, of course, present the new features. Well, I don't know whether people on this call are active Xpress or Mosel users. Just a quick introduction to what I'm talking about. Well, Xpress Mosel provides a high-level modeling language for formulating mathematical programming problems. And this language also provides standard functionality of programming languages so that you can implement your optimization models and solution algorithms in a single environment. We have a modular architecture that is open, that is, the interfaces are documented, so you can write your own additions to the language without any need for Xpress developers to interact with you to change the core system. The Mosel language is compiled and platform independent, so a model is compiled to the Mosel virtual machine, and you can port it across different operating systems. The language is designed to be easy to learn, and well, the idea is to get started quickly, but then if you like, you add modules, you add components, and you can go really well to very advanced features. The model itself can be embedded into applications via the compiler and runtime libraries, so the SRC or Java programs. You have the native interface. This is what serves to provide extensions to the language. And for working with Xpress Mosel models, we provide Workbench, which is a development environment. Its predecessor was IDE that is still distributed, but nowadays all new developments are happening in Workbench. Workbench also serves for the deployment and debugging of Xpress Insight applications. And then we have various tools, including a debugger and profiler, and also the Mosel doc tool to generate online documentation. Now, Mosel has started almost 20 years ago. The first version was released in 2001. Already the series of this first release has introduced the notions of parallelism. Mosel 2 has built out on data structures and problem types. And the Mosel 3 version has introduced the generalized notion of Mosel distributed framework for distributed computing. In Mosel 4, we have introduced, among others, native language support. We switched to UTF-8 as the default representation. And the present series Mosel 5 was started last year. And as you can see, there are many programming features again. But just a graphical representation. What I was saying previously, we try to keep the core small. So we started off with a bit over 50 subroutines, with few extension modules, and then skipping to the next release, you see many solvers added, some utilities. And you see over the time, while we're building out the open source portion, so these user extensions, so modules that are provided with full source publicly. And you can see the recent releases add data interfaces, many programming utilities. So this is where we are nowadays. And in these almost 20 years, well, we have just about doubled the functionality in the Mosel core, and everything else is in different modules, so that we do not render the language itself, the core of the language, too complicated. Now, what have we got in this new release? As you've seen in the graphics, in these last few years, the main efforts have gone into programming features, because this is what Mosel is being used for more and more. This time, what we are offering is the possibility to clone models. That is, a model that is already loaded in memory gets duplicated. So we produce a model from an already loaded model. Once we've got this, we can share data between such cloned models. And as an example of this, we provide an implementation of a multithreaded HTTP server, which also comes with some extensions of the mmhttp module. Another big feature of this new release are constants of native types and records. And then string concatenation, an improved implementation that speeds up quite a bit certain bad cases. We have a lot of additions to data handling, by the diskdata format and general data input features for spreadsheets and databases. We have new forms of the sorting function, so we need a generalization of the existing queue sort, and various other system functions. I'm going to go through these a bit more in detail, of course, now. Okay, well, first topic, cloning and sharing. I see there's a question, so I should just answer this question. So question was whether the webinars are available. So we are recording these webinars, and they are being made available afterwards. Okay, so cloning and sharing. First step is how to clone models. What we are doing is, well, of course, we're working with submodels. So we have one master model, and this master model loads other models into memory. We load these other models in the first instance from some file, and then we can clone the submodel to duplicate it. We do not go back to the source again, we just duplicate the information that is already held in Mosel memory. And well, this is a prerequisite for using shared data structures. And it can also be useful in situations where you actually don't have access to the original BIM file. You don't know its name, you don't know its location on a file system, so a model can just duplicate itself. Well, here is an example of what this looks like. The red form is the new form. So this MA is a of type model, so existing jobs functionality. And the second version, loading from test model.bim, this is the existing form. Well, I take a BIM file, I load this into the model object. Now, I'm doing this for the first one, just for the counter 0, and then I can just clone, so duplicate this exemplary, this instance that is held in memory to form further copies, so further clones of it. Or go back, as I said, to the original BIM file. Now, there is, of course, an effect on speed, just video slide effect. So here I have two examples with relatively large BIM files. One was 750 kilobytes and the other one was almost 4 megabytes of BIM file, which is quite large actually. Most models are considerably smaller. But the first one is almost not measurable in terms of time. Then all 10, well, it's also very small times. You see, if I do the cloning, it becomes slightly faster. What is more interesting here, particularly for the large model, is actually when I'm cloning, I'm sharing certain portions of what is in Mosel memory between these models. And the total memory usage goes down for this case by almost 50% for these. Well, I have actually the master plus 11 clones, so 12 models altogether. Now, I've got clones. I can share data between such cloned models. The structure of data cannot be changed while it is being shared. However, I can change values. Say I have an array, so I can, of an existing array entry, I can change values, but I cannot create new entries or delete existing array entries. And sets and lists cannot be modified while they're being shared, just to guarantee consistency of the data representation. There is a parameter, sharing status, that indicates whether a model shares any data, whether it has definitions to share data, and whether it's actually in use or not actively sharing data right now. So this is the picture of what we have had so far. Within a Mosel instance, I have a master model that has some data. Then via the SHMM, so the shared memory driver of the mmjobs module, I can copy this data into some location that is accessible by other models. And then I have a submodel started by this master that running within the same Mosel instance that can access the data. But each of these models takes a copy of the data into their own space. Now, this works also if the submodel is running on a distant, so on a remote Mosel instance, and the shared data in this case can reside on the instance that has the master or on the instance that has the submodel. Now, this is the new picture. So we are entirely getting rid of these additional copies of data. So the shared data lives in the Mosel instance, within the master model of the Mosel, but in a Mosel instance. The clone obviously needs to live in the same Mosel instance, and it immediately has access to the shared data without any additional copying step. Now, how do I specify this? Well, I have a new keyword. This marker shared is added in front of the array or any other data definition. And this shared data here, this is just a small example. I have an array that is marked as shared. I have an object model, and I have an indicator parameter that tells me, am I the master model or is this the submodel? So if I'm not in the submodel, then I'm populating the array with some values. This is then the master. I've just put 1, 2, 3 into this. I clone this present model. And I'm saying, well, now I'm running this clone, my model M, saying now this is going to be a submodel, and I'm just waiting for it to finish. Now, if I'm, now in this case, I'm running this, so I'm entering this portion here in the submodel, and I'm saying, well, these values of the array, but I'm just adding 1 to every existing value of this array. You see, there is no additional need for doing anything about this data. It is just there because it has been shared by the master. But I'm waiting for the submodel to finish, and now I'm printing out the result in the master, and it has now 2, 3, 4 as values. Now, this is of course just a tiny example. Why would I want to do something like this? Well, we've observed several times that there may be very expensive, computationally expensive data pre-processing tasks before an optimization model is started. And so one may want to think about ways of parallelizing these tasks. So here I have shown various definitions of, well, an integer scanner that is shared, a range set that is shared, a set of string that is shared, and two arrays over these sets that are being shared. And I've again the same setup. I'm using a parameter to indicate, well, am I in the master, which is index 0 here, or in some submodel, and the submodel will have indices 1, 2, 3, well, up to 5 actually. This is also the number of submodels I would like to create here. Now the master is going to run a routine one master, and if I'm not in the master, then I'm going to do some treatment on data, calculate some information. So the master reads data from some external source. It generates the clones, runs these clones, and waits for them to terminate. And if I have no further use of these clones, for instance, for some second computation task, well, then I unload them just to get rid of them, so free up memory. So reading data, running the clones, and then the master can go on with its own processing. So this was the master. Now the clones, they are just doing a single task. They do some calculation. I'm passing on this parameter m to distinguish which chunk of data is to be calculated by this particular model. And then, I'm assigning values. So this was a shared data item. The sets are of course shared, and then the result is also some shared array. And of course, via this parameter m here, I'm making sure that there are no overlaps between the results. Otherwise, if there are overlaps, the last one that writes into the result will be the final value of this result. Okay, so any question at this point?
None in the loop so far. We had one person raising his hands until now. So please, to everyone, if you have any questions, please raise them here in the Q&A at the bottom of the Zoom meeting, and then Susanne will answer in between, or we will answer in the chat directly. Okay, back to you.
Okay, so one example of using this shared data, cloning a shared data functionality, is provided immediately within the Express release in the form of an extension of the mmhttp module that allows you to define multi-threaded HTTP servers. What you already have for some time in the mmhttp module is the possibility to define an HTTP server or an HTTP client through a Mosel model. The requests, a client sends requests to some server, doesn't have to be a Mosel server, and the Mosel HTTP server receives queries from clients. Again, these clients can be Mosel models, but don't have to be, so any HTTP client. And the server has a query queue and deals with the incoming requests. Now, potentially these requests could be time-consuming. So, for instance, even some optimization ones. So in this case, the server will be quite busy just doing these jobs. So what we can do now with this cloning functionality, the server duplicates itself, various clones, and any incoming queries are copied or pushed through into a shared queue of events. And these server clones, they just pick up whatever is the next available request in this shared queue, handle them, and reply immediately to the original client. So here I can create any number of clones, but not really any number. It should match the number of processors you have on the machine that is running these things. But this way you can be much more reactive, handle many more queries, because you just record these queries and ship them over into a queue that is being dealt with by multiple Mosel models. This example is displayed in full in the chapter mmhttp of the Mosel language reference manual. Now, coming to the next big topic, constants of native types and records. Any questions regarding the HTTP servers? Okay, well, doesn't seem to be the case. Now, let's take a look at what are constants. Well, again, a new keyword that I can add to the definition here, for instance, of a set. So this is going to be a set. It's not the set that is becoming a constant, it's the components, so the elements of the set that are being made constant. So here this is the SD, it's the set of dates, so the standard definition, and now SDC is a set of constant dates. And what I can also now write is for a type such as date that is not one of Mosel's basics types, but it is provided to one of the modules. It comes from the system module. I can write equality here. So this is going to be a constant. So it cannot be changed and it's going to be unique. So why would I want to do something like this? Well, this is the set I have by the standard way of handling sets of dates. I'm creating a date from by 24 March 2010, and then by the next one, so just +1, so the next day. If I have now this constant here, which is the same, I mean, it's just the same numerical values. I'm testing whether this is contained in the set. And annoyingly, I'm going to get back the answer false because well, this is not a set of constants, so the elements in this set are not unique, but they have the same, they represent the same value, but the element itself is not unique. Same for tomorrow, well, this today +1, I'm getting back false. And if I'm adding the same things again, while I'm adding up, there's a set of size 4. Now, doing exactly the same thing with a set of constant dates. So same definition here. And now I'm testing is today. So my constant that I've defined up here, is this constant contained in a set? And now I'm getting the desired answer that it is true. So there's only one object representing 24 March 2010. And if I do a +1, so the next day, again, I'm getting true here. So this is again a unique object. But I'm generating these elements again. And if I do a plus equals, so I'm adding them into the set again, does not change the set size because they're already contained in the set. And I can do the same thing with records, but only records of simple of basic types, so of scalars and scalar types, integer, string, real, and boolean. So no structured types and no external types here. Then I can have constants by immediately assigning the record fields here, or I can have a set of such constant records. So here I'm creating some constants. Again, the standard definition is standard set of this record and a set of constants of this record. Now, again, I'm doing this test. Is this contained? This constant I've created here. False for the standard set, true for the set of constant records. And again, in here, I'm creating new objects, and again, false and true for this. Okay, and again, addition, exactly the same behavior. Well, why would I want to do all this? Well, the important thing is that by having unique elements in a set, it starts making sense to use such a set, for instance, a set of date, as an index to arrays. You could obviously write this previously, but as we have seen, if the elements in this set are not unique, then all kinds of nasty things could happen if you try to access the array elements. Now we know if we have, for instance, here the 1st of January 2020, well, this is unique. Whenever I create this again, well, it's just going to be this one element. So I can use this for indexing an array. And well, here I'm just getting the desired output. If I'm changing something here, I'm actually changing the desired element and not a copy or something like this of it. Okay, so this means we can take date and what's the other types, time and date time as index to arrays. Yeah, this makes it possible, for instance, to represent time series and many other features. Just leaving this to your creativity. Any questions at this point? Yeah, looks like the audience is way quiet today. So, well, if you like, just collect your questions for the end and well, ask them when we come to the end of the presentation. Next topic, string concatenation. Well, we have two types of representing strings in Mosel. The basic type is string, and then we have another type, text, that is meant to be used for any kind of handling, concatenation in particular of string. However, the type string is the basic type. So if you just surround some text with quotes, single or double quotes, you end up with a string. If you want to have a text, well, you need to explicitly make it a text. So in many cases, for instance, if you just write some messages for reporting, you just don't think about, well, working actively with text. And so you're using strings for generating your output that are mainly used or meant for quick access to, well, array elements when you use strings as index sets, for instance. Now, what we have in terms of new functionality. Well, this is something that occurs quite frequently in the generation of output. While you have a concatenation of some text with some result values, and well, here I've just used random values, but this is something that I've seen frequently in this form or similar forms in Mosel models. What happens here? This is just a, well, I have not provided any type definitions here. I'm just starting with a string. So all the rest will also be treated as strings in Mosel. What happens with previous versions, for instance, 5.0 of Mosel? Well, I need a certain amount of time. Well, this is just 10,000 iterations. So it takes some time because I'm actually saving in memory, in Mosel memory, all these intermediate strings that are used to build up the final string, which is the whole chain. And you see I have, well, quite substantial memory use that can be measured out of this. Now, for the new version, well, there is still quite a substantial memory use, because of course these 10,000 concatenated objects are going to be in memory in the end, but substantially less, and it is faster. I can construct really more noticeable speed up. So here is another case. So the previous was just storing the result into an array. Here I'm using concatenations within a void NN. So I just do some concatenation in order to generate my output. I'm not interested in storing these intermediate chains or anything that is within my void NN. Well, what happens in Mosel, previous versions of Mosel, all these intermediate chains do get stored. And in new versions, they do not. So depending on the N, 1,000, 10,000, 100,000, new version, you see constant memories because I'm just not storing anything. For the old versions, where this quickly goes up and uses a lot of memory. So addressing this problem of, well, if you use concatenation with plus, if you use the recommended form with commas, then also in any previous version of Mosel, there is no problem whatsoever. So this explosion of memory use in previous versions comes from the use of the plus sign from concatenations instead of using the comma, which is the version we show in all our examples. But many other programming languages just have this plus sign for concatenation for output. So it's just something many users are used to, and it just appears very often in model examples that we're seeing. So now there is no problem anymore with actually using this form. There are some other additions to string handling. So we can now create times, date time and date from strings, from text, sorry. Previously this was only possible from string. And the sum operator, which is certainly quite rarely used only, that was previously inversing the order of the individual elements, now maintains the order of concatenation, plus equal, which is probably something that's more frequently used in this context. Well, always behaved as expected. Okay, any questions to this topic? Now coming to data handling features. First of all, diskdata. Well, this is the functionality we have in diskdata. This format is actually a legacy from Mosel's predecessor, mmhttp. So this was the text data format of mmhttp, and we have initially provided it just for a transition period and to be able to read data files written for the old modeling environment of Xpress. Now, as it turns out, certain users have continued to use it, and this is a very efficient text, well, CSV style, separated text file reader. So what we have decided to do now is actually to extend this format. As I said, this is very efficient. It is limited in functionality. We do not want to bring it to the same functionality as the CSV reader that comes with the spreadsheet drivers, but we've extended it without changing its performance. So what we have, simple comma-separated file format with exclamation mark as comments, just as the Mosel text data file format. And this data takes two forms. This is also a feature that certain users like. You can use this as well, a driver with initialization is format true, or you have the functional form to get to the same data. This format assumes that you only have a single table in your CSV format file. So just single table per file, so very simple cases. Now what we have added is the possibility to use new types, in particular lists and sets and arrays of booleans, and also of native types, date, time, date, time. We have extended somewhat the format, so the CSV style format that accepts, for instance, a header file, so field names, and well, for the driver and also for the functional form. We have added various options to this. One option, auto-indexation, is new not only for this driver, but I'm coming to this in a second for all data, database and spreadsheet drivers. Auto-indexation means my data file only contains values, and the Mosel model doesn't have the indices either. But I'm saying, well, while I'm reading, I would like to generate indices, and I can specify the start value. Default start value will be applied here as being 1. Otherwise, here I'm fixing 5. So here the start value is 5. Okay, another new option, empty index. Well, here I'm missing one index value. By default, Mosel is going to stop here and say, well, there is no index value. I can skip this one, and this is going to be treated as the default value for this type. So for a numerical index, this would be 0. For a string index, this would be the empty string. Given that I have a CSV format file, I can specify the field separator, particularly for European users. Some languages apply the comma, other languages apply the semicolon as field separator in CSV files. I can switch between these different formats. And I can select columns via their headers. So column col 1, col 2, col 3. I say I only want to have col 3, col 1 and col 3. One difference to the standard CSV driver is they must be in this order. I cannot say, well, first read column 3 and then column 1. This is not possible with this driver. In the functional form, I cannot specify this column selection. Alternative form of column selection is just by order numbers of these columns. Okay. Any questions at this point? Now coming to the spreadsheet and database drivers. I have mentioned the auto-indexation for diskdata, and we have the same new functionality for the spreadsheet and database drivers. Here, for instance, the example of the mmhttp XLS driver, but it will look the same for the CSV driver or the Excel driver contained in the mmhttp module. What I've listed here is something that, well, many users are not aware of. I have a large number of possibilities of accessing spreadsheet ranges. I can specify a range by columns. Here I'm just saying take everything that is in column A. I can use the row column notation, so from row 1, column 1 to row 10, column 1. So I'm in the first column, I'm reading 10 fields. Here I'm using, again, just the column selector with specifying some other index. As opposed to the no index setting, for auto index, I can actually read several arrays at the same time. So here I'm using columns A and B to populate 2 arrays, and I'm generating at the same time the index automatically. Now, what I'm doing here, I'm actually populating 2 different arrays from the same column. So I'm saying, well, use the same column twice. And here I have selected larger range, and I'm actually populating arrays in some different order of columns within this range. So this is G, this is D, and this is E in terms of columns. If I don't have any sector here, then this just means I take anything that is found in this particular spreadsheet. And here I'm taking something is titled column 1 and column 2 in the spreadsheet. For database, of course, the matters are a bit different. I always need to specify tables, and what I can put this wildcard or specific field names from a table, and the auto-indexation and the index are set via parameters. Another new feature specific to spreadsheets this time is the possibility to retrieve range informations. On the previous page, I have talked you through the different ways of specifying spreadsheet ranges. And what one may want to do is actually, I have some selection, I don't exactly know what I have selected or how many data items are contained in a spreadsheet, for instance, and just inspect my spreadsheet and report on this. The return type here is going to be list of integer, which is 2 values, height and width of the rectangular area that I have denoted by my selection. So here, empty sheet. So it takes the first spreadsheet, or in CSV, just the one sheet. This is the second sheet that is contained in my spreadsheet. Then it looks for a sheet called data and takes anything in there. My next one is column selection. Whether I use lowercase or uppercase does not matter. But numbers, here I have in a spreadsheet a predefined range, which is set within Excel to create the range name. And coming to the row column notation instead of the alphabetical with numbers. Okay, so these are different cases, different ways of referring to spreadsheet ranges. Just have this again together on a single slide. Empty index, just similar to what we've seen for this data. And another option, so now this was all for spreadsheets. But of course, ranges reporting on database tables has other functionality that is already available for just SQL statements. Now here for database drivers, we have another setting. Actually, it's a control parameter that shows us when I am writing to a database, has everything been output correctly? Maybe that I have some very large text field and my predefined sizes, column width, so number of characters per database column was not large enough to fit all the contents in. So now this truncation size control tells me, has anything been truncated? By how much do I need to increase my column widths or field widths to be able to get across all the contents that I have, that I would like to write? Okay. Any question at this point? So then now moving to another data handling or programming feature, which are new forms of QSort. QSort now makes it possible to use many more types, and in particular, the date and time types. Well, actually any types that define the odd property. Now, what does this mean? If I'm typing at the command line, Mosel exam -t for types, and then the name of a module, I'm going to see output like this. So I'm seeing the types defined by this module, and then a number of encodings, so the properties that these types implement. Well, this was the output with previous versions, Mosel 5. And now you see the Mosel version 5.2 has new markers. So actually now I have a ordering property defined for these date and time types. These date and time types can also be made constant, which is not possible for text. I mean, text by definition need to be dynamic. And that's another feature, but I'm not going into detail about this one. So here we are concerned with any types that have the ordering property. These can now be used in QSort. So in particular, a list of dates can be sorted in this up or this down, so increasing or decreasing order. But this is not all. So far, QSort has only been able to work with one criterion. So I have one array and I want to order this array. Now, what about situations where the array is not unique? I mean, the values are not unique. So I want the second array to break ties. So here I have two arrays, C1 and C2, even of different types of data. And I would like to sort. So I'm first sorting with C1, and then I'm sorting based on C2. So my output is going to be the first numerical values, 1, 2, 3. And then for breaking ties, I'm looking at the values of the second array, and I'm putting these into the correct order. Correct order means, well, I've put this up, so moving upwards for both arrays. Now, this can be extended even further. In the case that I want to compare other objects, for instance, a record that I have, my record type that I've defined myself, I can implement a comparator function that tells me how to compare these types. Mosel has a new built-in compare function for simple types. So for these basic types in the record, I just have integers, for instance. This is built in, but anything else, how do I compare this record? Well, I'm first comparing on the value v, and if this is not sufficient, well, I'm taking the second record field to return, well, the comparison information. And this comparator function is passed as a callback to, as an additional argument, to the QSort routine. Sorting this array C, and these are the result. Okay, so now various other new features. For users working under Unix systems, well, Mosel has supported symbolic links in various places already in the past. We have now functionality in System to actively create symbolic links. So here I can create a symbolic link onto a file. Always check the system status information, whether actually any kind of system operation was carried out correctly. I can access a link and then, well, test the status of the file that this link points to. So it's a specific status checking routine for links, whether this is a link. Under Windows, this is not going to work because the notion does not exist in this form. We have new options for tar and zip to have verbose or just listing all files that are being compressed or uncompressed, and whether to stop on failure or just skip problems. Another update that we have made are the newest versions of the various external libraries that we depend on, in particular for encryption, the OpenSSL library, and then SQLite for databases, and libxl, which is the driver behind, the library behind some of the Excel, spreadsheet drivers. A new form of the exam command makes it possible to inspect files that cannot be loaded. Users who have updated or are in the process of updating from Mosel 4 older versions to Mosel 5 may have found that sometimes the combination files or loading fails for an existing file that comes from an older version. Now, it's difficult to tell what may be going wrong if I cannot load this file. So what this exam minus uppercase H allows me to do is to display just the header of the BIM file, in particular with the list of dependencies. So the other modules, the other libraries that this particular BIM file, be it a model or a package BIM file, relies on. So then I can check, have I got these dependencies in my search bar, so in my Xpress installation or in a location pointed to by the Mosel _ DSO or Mosel _ BIM environment variables. We have also made a change to the default compatibility convention that is applied for BIM and DSO. So if you write your own package or your own DSO and you do not write specific conventions for DSO, this is what gets applied. The new convention is more relaxed. Previously, we have the release, major, and minor. Previously, the rule was checking the minor number for, needed to be larger or at least the same value as the new one to have a compatible case. Now we're just checking the first two pieces, so the release and the major number, to see whether versions are compatible. The set for people writing a DSO, and this is the case for most DSO that we are providing, there are specific rules in place that have a notion of minimum required version, depending on the functionality you're using. Okay, most of these features I have presented today are presented or documented in the Mosel language reference menu, in particular these new keywords shared and constant, and then all these different extensions to the various modules I've mentioned, HTTP, jobs, the various data handling models, and white system functionality. Some of these carry through to libraries, in particular NodeMod for the cloning, and some also are in the native interface reference menu. Okay, so with this, I have reached the end of my presentation for today, and we have a couple of minutes for questions from the audience.
Great, thanks a lot, Susanne. I have received one question here, which is, and I think you have to go back on your slides. So in Mosel 5, the type contained CMP. Now it's odd const bin, and what exactly is bin? So people, I think, would love to hear more about. Maybe you can just repeat what you demonstrated today.
You mean this page here?
I think this was when it came up, yeah? Yeah, makes sense.
Okay, so bin is actually whether this type can be used with Mosel's binary format. So whether it provides automatic representation in Mosel's binary format. This should be explained with the bin driver also in the Mosel reference manual.
Okay, great. So again, to the audience, if there are any questions, it's your chance to type them into the Q&A or raise your hand and we wait until you've finished typing.
Should perhaps add at this point, you have the Mosel exam and then, well, various letters. I've shown this minus uppercase H. This exam command is in the introductory section of the Mosel language reference. There you get an explanation of all the different options that you can use with the exam. But the functionality really is to inspect modules, packages, or MM systems, so DSO files, and to see what functionality do they define and, well, actually do they expose publicly.
Susanne, I received another question.
Yes.
So it's about the shared data structures. So I think cloning and sharing might be the topic. How about ensuring deterministic behavior? Maybe you can just comment a bit on this.
Well, this is up to the person. Well, this is up to the person writing the model. So here, what I've in this instance is I'm loading, then I'm setting all to 1, and I'm waiting. When I'm actually here, I'm waiting for each of them individually to terminate. And then I'm unloading. I can, at this place, I can say wait, and, well, the queue of the events I'm receiving, well, I can, well, reorder priority, for instance, in which one do I want to terminate first. If I, well, wherever I say run at the same time for models, they are just going off, they are running in parallel, and this is entirely non-deterministic unless the individual submodels have coordination mechanisms. So they need to, if you want to have this deterministic, then you need to have meeting points where you coordinate your different submodels. But by default, whenever you say by this runs, they just go off in separate threads, and well, you just have no influence. I mean, this depends on your system. With different, while you run this a second time, it may, well, end up, well, a different model may end up terminating first. So this is always non-deterministic unless you program yourself the determinism into this.
Right. And thanks, Susanne. Seems there are no other questions. I think we are almost at the end of the hour. So thank you everyone for joining this webinar. If you'd like to receive a copy of the recording of the slides, please shoot an email to Joe Nguyen. So you saw that maybe in the Q&A with his email address. You can also use the mail address that came with the invitation. Now, it's my pleasure again to thank you, Susanne, for presenting. Good stuff you've developed, and hope to see everyone in the audience in one of our next webinars. Thank you.
Bye, everybody.